In this video, I'm going to show you how to display probability information in a tree diagram. In this example, a play is holding performances in both the afternoon and evening and is selling tickets to both adults and children. We've been given a completed two-way table, which we need to use to fill out the tree diagram. The tree diagram has already been drawn for us on the right side. The highlighted yellow portions next to each branch will need to be filled in with probability values, and I will explain how to calculate those values as we go through the video. Now, you might notice something different about our two-way table. In the past, our two-way table has been filled with frequency values, which were whole numbers because they represented the number of people that went into each category. This two-way table is filled with decimal probability values. So instead of telling us the number of people in each category, this tells us the probability of someone falling into each of the categories in the table. For that reason, our total is adding up to 1 because our probability values always need to add up to 1. Now, this is actually going to make it a lot easier to fill out the probability values in our tree diagram because the table is already converted to probability values. If we look at our tree diagram and start at the top, we see the word tickets. Tickets are split into either adult tickets or child tickets. So the branch on the left goes to the word adult and the branch on the right goes to the word child. We're just going to focus on this top portion for now. We need to put the probability of a ticket being for an adult on the left branch and the probability of a ticket being for a child on the right branch. I've already written these probability statements below. So we can start with the probability of a ticket being for an adult. This tells me to go to the adult column in my two-way table and go down to the total probability that a ticket is for an adult, which is 0.66. Now I can place this value on the left branch under tickets, going to the word adult. Next, I can do the same thing to find the probability that a ticket is for a child. I'll go to the child column on my two-way table and down to the total to see that the total probability that a ticket is for a child is 0.34. And I can place that value on the right branch under tickets, going to the word child. Now we're ready to move on to the next level of our tree diagram. Let's start on the left side where we see the word adult. Under the word adult, there are two more branches. The adult tickets can be split into afternoon tickets and evening tickets. Now, since we're only looking at the branches underneath the word adult, we're only going to be focusing on adult tickets for this portion. So we need to find the probability that a ticket is in the afternoon, given we already know it's an adult ticket, and the probability that a ticket is for the evening, given we already know it's an adult ticket. So since you heard me say the word given, you know we're talking about a conditional probability statement. So let's start by finding the probability that a ticket is for the afternoon, given we already know it's for an adult. This is going to tell us the value that goes on the left branch underneath adult. Since we've been given the condition that the ticket is for an adult, we can use the circle and check method in our table. We need to circle the area of our table that focuses on the given condition, which is that the ticket is for an adult. So I'm going to circle the column labeled with an adult. Now, for the check portion of our method, we need to check off the probability that we're looking for. And we are looking for the probability that the ticket is in the afternoon. So I'm going to go to the afternoon row and stay in that column and check off the value 0.16. Now, to calculate this, our denominator is always the total probability for our condition. And the probability that a ticket is for an adult, which is our condition, is 0.66. So that goes into the denominator. In the numerator, we need to put the number that we checked off, the probability that a ticket is for an adult and for the afternoon, which we checked as 0.16. Now I can calculate this in my calculator. 0.16 divided by 0.66 gives me 0.24. Now I can place this value on the left branch underneath adult, going to the word afternoon, 0.24. Now let's do the same thing on the right side of the diagram. Let's go over to the word child, and child is also broken off into two branches because those tickets can also either be for the afternoon or for the evening. Let's start with the left branch under child. We need to find the probability that a ticket is for the afternoon, given we already know it's a child ticket. So since our condition this time is that we're just looking at the child tickets, we're going to circle the column under the word child. Now I need to check off the probability that I'm looking for, which again is the probability that the ticket is in the afternoon. So I go to the afternoon row and stay in my child column and check off the number 0.13. My denominator is the total probability that a ticket is for a child, which we already know is 0.34. And the numerator is the probability that the ticket is for the afternoon and for a child, which we checked off as 0.13. Now I can put this in my calculator. 0.13 divided by 0.34, that gives me 0.38. Now I can put that on the left branch underneath child, going to the word afternoon. Now we only have 2 more blanks to fill. We need to find the probability that a ticket is for the evening, given it's for an adult, and the probability that a ticket is for an evening, given it's for a child. This we can do actually a lot easier than the circle and check method. Since we know that every single adult ticket needs to be either for the afternoon or the evening, and we already know that 0.24 of the tickets are for the afternoon, then all of the remaining tickets must be for the evening. There's no other possibility for the tickets. So since we know our probability for afternoon and evening needs to add up to 1, I can take 1 minus the probability I already found under adult, which is 0.24. So when I subtract this, that will tell me the value I need to place on the other branch to ensure that they add up to 1. So I can do 1 minus 0.24, which gives me 0.76. And that is the value I will put on the right branch underneath adult, going to the word evening. So we know that in a tree diagram, every set of branches needs to add up to 1. So that means whenever we have one of the branches, we can just subtract that value from 1 to get the other branch. So for underneath child, we can do the same thing. We already know the probability of the ticket being for an afternoon, given it's a child, is 0.38. So 1 minus 0.38 must give us the remaining probability that a ticket is for the evening, given we know it's a child. So 1 minus 0.38 gives me 0.62. So I can place that value on the right